like, share and subscribe and press the bell icon.
Hello everyone. So in the previous video we have learnt about polymers. That is, what do we mean by polymers, what type of substances are called as the polymers. Then we have also learnt about monomers, what do we mean by monomers, and repeat unit. Then we have gone through the classification of the polymers, and there are different ways of classifying polymers. That is, we have already studied about polymers on the basis of the source, where we learnt about the natural polymers and the synthetic polymers. The second way of classification of polymers was on the basis of their structure, where we learnt about the cross-linked polymer, branch chain polymers and the linear polymers. Now we move on to the third type of classification, that is classification on the basis of mode of polymerization. So here we have it, that is classification on the basis of mode of polymerization. That is, how does the polymers are being formed, the process by which the polymers that has been formed, that is a mode of polymerization. So on this basis we are having the two main types of polymers, that is the addition polymers and the addition polymers. Obviously they have been formed by addition polymerization reactions, and condensation polymers, obviously they have been formed by the condensation process. Now let me just give you an example then of each of the type, then we will discuss what exactly they are. So we first of all we come to the addition polymers. Okay, so we come back to our same example of ethene. It undergoes polymerization. We can write down over here polymerization or the addition polymerization reaction over here. First we will see how does it takes place, then I will just show you. So here this will be CH2. Okay, so this is what, this is a monomer, and if you are not writing down in bracket, this will be just simply, this will be the repeat unit, simply this way is a repeat unit. I repeat once again, this is the monomer for formation of polythene. This is a repeat unit. When this repeat unit is n number of times, it leads to the formation of polythene. So this is your ethene, this is polythene. Okay, so look here, in this particular case what is happening over here, the monomer that we are starting, it is an unsaturated compound. So usually in case of addition polymers, what happens, the monomer that we take will be the addition will be your unsaturated compound, which will undergo the addition reaction over here. That means these monomer units will join up, leading to the formation of long chains. Now when they are joining up, there is this reaction mechanism. How does it occurs? This reaction occurs through a certain mechanism. So this mechanism, that is, it proceeds through formation of certain active centers. Formation of active centers. Now active centers, what are the active centers? Active centers are the centers, that is intermediate species, which will be active. Now why, when they will be active? Obviously, suppose if they are forming some free radicals, or if they are forming some carbocations or carbanions. If you remember, free radicals, that means having the electrons with them, so they will be active. We have learnt in the previous class. And carbocations, that means what, carbon having the positive charge, carbanions, carbon centers having the negative charge. So if this proceeds, like a long chain will be formed by just the addition of the monomer unit. And in this, can you see, that is, it is undergoing an addition polymerization reaction. So this is formed by addition polymerization, and in this case you can see that the repeat unit is same as the monomer unit. Why the repeat unit is same as the monomer unit? Because in this there is no loss of any molecules, such as your water molecule, NH3 or alcohol or any other molecule, alcohol, etc., or any other molecule, no loss has been taking place. So no loss of any molecule such as water molecules, ammonia or alcohol is taking place over here. Simply addition reaction has been taking place. Addition of what? Addition of the monomer unit. So this, the repeat unit is same as the monomer. This is the monomer, this is the, if you are not putting a bracket over here, simply if you are writing down over here this way, that is, this is a repeat unit. So this repeat unit n number of times it is giving rise to a polythene. Okay, so the repeat unit is same as the monomer unit. There is no loss of anything over here. There is no loss of any of the molecules like such as water molecule, ammonia molecule. Simply addition is taking place, and this polymerization reaction we call this as the addition polymerization. So obviously the polymers formed by this way is called as the addition polymers. Let us come to another example of this formation of addition polymerization, that is propene. I am writing down over here. Let me rub from here, that is, so this is our second example under addition polymerization. Second example over here, that is NCH3 CH double bond CH2. It will undergo addition polymerization. So this is the propene and this is polypropene. Polypropene. So in this case also, if you just simply write down the repeat unit, this is the repeat unit. So this repeat unit is same as the monomer unit, and here also we will find that there is no loss of any water molecule. So these types, simply addition of a monomer unit is this is a monomer. This is a monomer, this is a repeat unit. So simply addition of the monomer unit takes place, leading to the formation of the long chains. That is, from propene we are getting polypropene, or we also call this polypropylene. We get this name from propylene. If we call this as propylene, then this will be called as polypropylene. But both are same, propene or propylene, both are same. So this is how addition polymers that has been formed. Next, let's move on to the next type of polymers under this category, under mode of polymerization. So condensation polymers. So second type under mode of polymerization, the second type of polymer, condensation polymer. Okay, so let me give you an example here also. Here hex. So look here, your loss of water molecules takes place at each step. So here look here. So this is the reaction in hexamethylene diamine. This is one monomer. This is adipic acid. This is another monomer. So two monomers are being joining together over here. So joining by condensation. There is a condensation has been taking place over here. So here in this particular place, what is happening that at in the water molecules are being lost from here. So when there is a loss of any molecules such as water molecules or ammonia molecules or alcohol molecules, and the reaction if it undergoes, that is condensation process takes place, this type of polymerization is called as your condensation polymer. So we can say a series of condensation reactions takes place between monomers having the many functional groups. So here a monomer containing one functional group, that is NH2. Here this is another monomer containing a carboxylic group, that is COH. So when we say that a condensation reaction takes place between the monomers which are either bifunctional or maybe that means it contains the two or more functional groups over here. So here two functional groups are being involved over here. So in this particular case, loss of water molecules takes place in the condensation reaction over here. So we write down over here 2NH2. So in this particular example, we'll find that the repeat unit, suppose if I am writing down this way, that is NH CH2 6 NH C double bond O CH2 4 C double bond O. So this is a repeat unit. This is a repeat unit for this nylon 66, and these are the two one monomer over here, another monomer over here. Okay, so the repeat unit is not same as your monomer units. Both the monomers are different as well as the repeat unit there has been different. So such type of such type of polymers formed over here, we call them as a condensation polymers. Let us have another example of condensation polymers. So we will take ethylene glycol, N molecules of ethylene glycol. Plus the phthalic acid. So from here also the water molecule, that is OH and this H, it will get removed, it will get in the process. So here, and at the same time from here also OH and this H over here. So what we will be getting over here? O, CH2, CH2, O, and this H is getting removed. So C double bond O. This will also be C double bond O. Okay, so this is a repeat unit. So this here, this is called as a ethylene glycol. The name is ethylene glycol. Why do we call it as a glycol? Because there are two OH group over here. Because of the presence of the two OH group over here, we call this as glycol. That is the two alcoholic group over here, so we call this as glycol. And two, that is two carbons. So ethylene glycol over here, and this is your terephthalic acid. And this compound, so this is the repeat unit, but when I am enclosing it into the bracket, so it gives rise to the formation of terylene. Okay, this is N over here. So this is how, this is also an example of condensation polymer. The loss of the water molecules takes place over here. At the same time, the repeat unit is not same. This is one monomer, this is another monomer. This is, here also it contains the two functional group, although they are same. But one OH over here, another OH over here. Here also one COH over here, one COH over here. So the monomers, they are bifunctional, polyfunctional, and at each step there will be a loss of water molecule in this particular formation of terylene. So this is what is your condensation polymers. Some few more examples of condensation polymers are nylon 6, then nylon 612, sorry 610, although it's not a part of the syllabus, just simply there as an example that you learn it. Bakelite, All these are the examples of the condensation polymer. Okay, so we have seen about the addition polymerization and the condensation polymerization. Now sometimes what happens, it becomes difficult to identify whether the polymerization has taken place through the addition reaction or through condensation reaction. So we got another way, the people find out another rational way of classifying the polymers, that is on the basis of growth polymerization. That means how the growth of a monomer unit has taken place to form the long chain of a polymer. So on this way, that is when this classification is not, when we get confused with the addition polymerization, condensation polymerization, that is when it becomes difficult to identify which type of polymerization has taken place. Then we come to the next type of, so we have another way of classification, that is how the growth of the monomer unit has been taken place on the basis of, so we call this on the basis of the growth, polymerization, which is called as on the basis of growth polymerization. So here on this basis of growth polymerization, again we are having the two ways of classifying. One is a chain growth polymers and another is a step growth polymers. So we'll first discuss about the chain growth polymers. Now chain growth polymers means growth of a monomer unit. Chain growth itself means that is a growth of a monomer chain. So this growth of a monomer chain, it takes place via the formation of certain reactive intermediates. That means what? Certain intermediates will be formed. Those intermediates will be very reactive. Okay, and those reactive intermediates, they can be either the free radicals, they can either, or they can be the carbocations, or they can be the carb anions. So this process, that is a chain growth polymers, again it is having three steps in this, that is the initiation, propagation and termination. Once more, let me make it clear to you. Chain growth polymers or chain growth polymerization, what does it mean? That is how does the growth of a monomer unit takes place, leading to the formation of a long chain. Now exactly how does it takes place? In short, I am telling you, that is a reactive intermediate has been formed. Those reactive intermediate, it can be either your free radicals, or it can be carbocations, or it can be carbanions. Those are very reactive centers. So once the reactive centers that has been formed, they will attack on the monomer, another monomer unit. They attack on the other monomer unit. So this way the chain keeps on growing, and in the end that growing chain, it has to be terminated. That is somewhere it has to be stopped, and that process we call this as a chain termination. So again, this chain growth polymers, it involves the three steps: initiation, propagation and termination. So first of all, we come to the initiation process. So as I told you, that the initiation process, that is the beginning, initiation. How does the initiation process it starts? So we have to take in, that is we have to introduce an initiator. There should be something which should be an initiator. Now an initiator is usually a benzoyl peroxide or any of the other peroxide, or it should be such that it should be a very reactive substance which act as an initiator. So here we have taken a organic peroxide. So we are heating it, this organic peroxide. Why we are heating it? Because we want to convert it into a active center in the initiation step. This is the first step. So we are converting into an active center. How we are converting? We just take the organic peroxide, we heat it, and look here there is a free electron over here. This free electron, finally this compound, there is an intermediate which has been formed over here, it finally breaks up, leading to the formation of 2R plus 2 molecules of carbon dioxide. So this is a free radical which has been formed over here. Now what is free radical? Once again, let me tell you what are free radicals. These are shortly lived, highly reactive species, and they are having the unpaired electron. You can see over here this dot, it represents the unpaired electron. There is only one electron over here, and it is short lived and it is highly reactive. So the free radical that has been formed over here, we have got nothing to do with this carbon dioxide, but we have got to do something with this. So look here, from this 2R we take one atom of this, or one, this one part or one of this free radical, and we are making it to attack on this another monomer unit over here. So that we have taken over here a monomer, that is an ethene over here. So here it is forming, again this R joins over here to the ethene. So this is forming what? Monomer with active center. So this is just, again, because the electron is over here, free electron is over here, so we call this as a monomer with active center. Now R over here, it can be anything, that is, it can be either your methyl group or it can be your benzoyl group. So R, it can be, we can introduce from here also as R, which is taken over here, it can be a methyl group, benzoyl group, any of this group it can be here, taken over here as R. So here it is forming a reactive intermediate. So this is the first step, that is the initiation step. The next step is what? That is this, just start it. Okay. Now this has to propagate, this has to continue further. So here this monomer with active center which has been formed over here, now it has to continue further. So we take the next step is a chain propagation, that is growth of this monomer unit with the active center. So again this one monomer with the active center, it has been made to introduce with another monomer over here. This monomer is with the active center, this monomer is not having an active center, that is, it is what? One molecule of ethene. It is introduced, it is treated with one molecule of ethene. So here total you see over here how many CH2? 1, 2, 3, 4. So here also 1, 2, 3, 4. And again this electron that comes over here, that is it is a dimer. We call this was a monomer, now it is again 2 units have been joined together. So we call this as a dimer with active center. Again this proceeds over here, again we are making it to react with another molecule of an ethene. So here it will be forming a trimer. This was a dimer, so after dimer it forms the trimer. So you count the total number, that is 1, 2, 3, 4 and this 2 over here, 6 total. So look here, 1, 2 and this 2, that is 4 over here, CH2 and this CH2. So instead of writing down so many number of times, I have just written down this within the bracket. So this is a trimer with active center. So again the electron, the free radical, that is a free electron which is there over here, it's still over here, because of which it is very much active over here. So we continue, this goes on repeating. Once the chain initiation and propagation has started, it will go on, it will go on and on. So here finally we don't know how many number of times it will go on, so we call this as a polymer with active center. So what we do, this is R, CH2, CH2 and we are showing it as a X instead of 2 over here, that is we are showing it X number of times, and this CH2 and this CH2 with an active center over here. So if we are not stopping it, this will go on and on, but we have to stop it. So we come to the last step, that is a chain termination, where you see that is this polymer with the active center, or we can say this is a growing polymer chain with active center. It is a polymer, but this polymer, that is a polymer with active center, it is going on growing. It is not stopping it. So we call this as a growing polymer chain with active center, and we take another growing polymer chain with active center. We treat it with another growing polymer chain with an active center. So here it is X number of molecules of this CH2, here also the same thing, but instead of X we are taking over here Y, that is Y number of these chains over here. Another growing chain polymer with active center. So when both of them they come together, this growth stops over here, and as the growth stops over here, we call this process as a chain termination. So finally we get this process, this whole process by which we get a polymer, we call this as a chain growth polymers over here. So 3 steps are involved over here: initiation step, chain propagation and chain termination, and finally we get our polymer over here. So here let me write down over here, there is a polymer which terminates. So polymer without active center, or we call this as polyethylene. Polyethylene. This is an example of polyethylene or polyethylene. Polyethylene or polyethylene. So this is here the process stops, so we can say this is a polymer without the active center. I hope it's clear to you, students. Just look at it very carefully. The 3 steps involved in the chain growth polymerization. Okay. Next we have step growth polymers. So next type of polymer on the basis of growth polymers is step growth polymers. So what does the step growth polymers means? What? That is in stepwise manner, in several steps. In several steps, the growth of the monomer unit takes place, leading to the formation of a long chain. Now, the monomers that you involved over here, they may be bifunctional monomers involved over here. They may be bifunctional or polyfunctional. That means having either here also two functional groups that has been involved over here. So either involving two or more functional groups over here. So either it may be bifunctional or polyfunctional monomers that may be involved over here. And in a stepwise manner, in each step, condensation reaction takes place. So the main thing over here is a condensation reaction. Condensation reaction takes place in each step. Now, it may involve the elimination of certain small molecules or may not. May or may not. Or may not. May not involve elimination. Elimination of what? Elimination of small molecules, elimination of either water molecules, ammonia molecules or alcohol molecules. It may or may not involve those elimination of those small molecules. But at each step a condensation will be taking place. And because as this process takes place in a stepwise manner, several steps, we call this as a step growth polymers. So what happens? One monomer, it reacts with another monomer. One monomer reacts with the other monomer. So obviously it is going to form two monomers are coming together, it forms a dimer. So this dimer now reacts with another monomer. So we will be forming the trimer. This trimer will again then react with another monomer forming the tetramer, and finally it forms in this way it goes on. The process goes on. It leads to the formation of a polymer. So in this we do not, that is the process just goes on, that is the monomer unit goes on growing without there is an involvement of any initiator. No initiator is required over here. It is we can represent this. Suppose if this is one monomer, this is another monomer. Both these monomers are coming together, condensation is taking place, it leads to the formation of a dimer. That is AB is a dimer. Now this AB, which is a dimer, again it reacts with another molecule monomer, that is A, again condensation. There may be elimination, may or may not elimination of small molecules. It is forming a trimer. This trimer, that is ABA, it is again reacting with B, that is again another monomer forming tetramer. And finally this goes on process until it forms a polymer of a high molecular mass. Goes on. So you can just represent with the dot simply shows that is AB is to N. There is N number of molecules of the monomer, that is your polymer that has been formed over here. So this is if you are not enclosing it into the bracket, this will be representing as your repeat unit if the brackets are not there. But N molecules over here, it represents the polymer over here. So here we have again the same example, that is our hexamethylene diamine, the reaction between hexamethylene diamine and adipic acid. That is formation of nylon 66, which we have studied some time back also. So here looking at your hexamethylene diamine. So here H2N, CH26 and H2. This NH2 just I have split over here, that is NH, and I have shown H separately over here to show you that elimination of water molecules takes place over here. That is this H from here and OH from the adipic acid. So this is one monomer, this is another monomer. Adipic acid is one monomer, hexamethylene diamine is another monomer. Loss of this water molecule over here takes place, so it forms this H2N, CH26, NH, because one molecule is lost over here, OC, CH24, COH over here. Okay, again this continues. So again we are introducing it with another monomer, that is hexamethylene diamine. So when it comes in contact with hexamethylene diamine, again there is a loss of water molecule. So what happens? This same thing over here, CH2N, CH26, sorry, H2N, CH26, NH, OC, then CH24. After this, what happens? That is CO. Look here, CO. Again this OH and H from here. This OH and H from here. That means one loss of one water molecule. So CO and NH. Again CH26, NH2. Clear? Just look here very carefully. This OH and one H from here. That means water molecule is lost from here. So after this CO, this we are forming over here NH, CH26, NH2. So this was a trimer, and finally this process goes on and leading to the formation of a polymer. So the polymer that is obtained over here is nylon 66 over here. Okay, so this was a fourth way of classification of a polymer. We have another way which will continue in the next video. Thank you, students.